My name is Tom, and in this video I am going to describe in detail a very simple example of relative motion. So, imagine we have the following scenario. A common example of relative motion, of course, is that of a boat in a river, and the river is flowing, and the boat either moves with the river or in the opposite direction. In this one, we are imagining the following. Imagine you're looking at the top of a ruler. Okay, so imagine this is a ruler, and you are looking at the top of this ruler. Okay, there we are. Now let's mark the ruler, of course. I don't know, let's take this to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there we are. This is our little ruler. And now what we will do is the following. We will move the ruler. But before we do that, imagine that everything that we do is counted relative to this. This is like the starting line, okay? So here's your ruler. We will pull it to the right. So imagine that now there's a guy over here standing right there. Okay? The green dude over here. Alright, there you go. Okay, so he's standing over here. Gotta give him some fingers. There we are. So there's a guy standing right here. There's this massive ruler compared to him. Okay? And we're gonna pull this ruler to the right. And say he's got a watch. And right now, before we do anything, let me draw the watch in a different color. Here's our watch. There we are, right? 12. We pull the ruler at a uniform rate, which means we don't accelerate it. It's always moving at exactly the same rate. Okay, and say it turns out that once we've pulled the ruler, that perhaps 5 minutes later or so, okay, 5 minutes have passed in our little magic clock, the ruler here has moved. Okay, so this will take a 0. Okay. Say the ruler has moved. And say the ruler has moved. So how wide is this ruler? Let's count down. 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, so let's do it to here. There we are. 1, 2, 3, 4, 5, 6, 7. Okay? And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 or so long. Okay, so we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So this is our ruler, okay? And it's moved this amount within an interval of 5 minutes. Okay? So make sure you can visualize this, right? Here's a ruler. And as time passes, the ruler moves to here. Okay? So you can tell that altogether that is an interval of what length here? 5, right? And let's say the units are centimeters for the sake of simplicity, okay? So this is 5 centimeters. That's how far the ruler has moved, 5 centimeters. Okay, so let's renumber the ruler. Let's take you 0, that's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. Okay, with a little bit of change at the end. Let's not worry about that, it doesn't really matter. So, within a passage of time of 5 minutes, okay, 5 minutes have elapsed on this guy's clock. The ruler has been pulled to the right 5 centimeters. That's what this is showing us. Which means that the velocity of the ruler, okay, what this guy sees as the velocity of the ruler, okay, we will label that as follows. V R on the guy's clock, right, on his watch. That is the 5 centimeters divided by the 5 minutes. Okay, so the velocity of the ruler, as the guy over here sees it, is 5 centimeters in 5 minutes. And of course, this is positive, right? It's to the right. Now, imagine this happens. Instead of moving just the ruler, on top of the ruler there is perhaps a little critter. Okay? Maybe a mini version of this guy over here. Okay? So I will draw a little green guy now on the ruler like this. Okay, there he is. And the following happens. Within the same 5-minute period of time, when the ruler has moved 5 centimeters, this guy here has moved along the ruler also 5 centimeters. Okay? Which means the following. When you look at the process 5 minutes later, this little green guy not only has he moved because the ruler is moving, he's also moved because he's moving relative to the surface of the ruler. So he runs and he ends up over here. Okay? So within the same 5 minutes, this little mini guy over here, right, the mini version of this guy over here, as time passes, the ruler moves 5 centimeters, but this guy here moves 5 centimeters along the ruler also. So now when we measure how far he has traveled relative to the big green guy, we can tell that that is this quantity, right? That is this 5 centimeters and the 5 on the ruler for a total of 10. Which means the following. That the velocity of the little green guy here, okay, I'm using him as the subscript, the velocity of the little green guy is the distance he travels, which is 10 centimeters, divided by the same period of 5 minutes. Okay. So relative to the big green dude, within the period of 5 minutes, the ruler moves 5 centimeters, but this little guy moves altogether 10 centimeters within the same 5 minutes. That is so because as the ruler moves, he moves along the ruler. Okay? So in other words, imagine it this way, right? To illustrate this process very carefully. Every time this ruler moves 1 centimeter to the right, the guy on the ruler moves 1 centimeter along the ruler. Okay? So how do you imagine that? That's not so easy, right? You've got to think about that carefully. So I will illustrate with another picture. I will make a smaller version of everything down in here. Okay? Imagine this is the very beginning. This is the ruler, right? And here's the guy standing on the ruler. 1 minute into the process, okay, the ruler has moved only 1 centimeter, and the little guy on the ruler has also moved 1 centimeter along the ruler. You see now there's a little gap between him and the edge of the ruler. And then 2 minutes into the process, the ruler has moved another 1 centimeter, and this guy on the ruler has moved another 1 centimeter along the ruler. You see how the gap between him and the edge is increasing? 4 minutes into the process, the ruler has moved another 1 centimeter, and the guy has moved another 1 centimeter relative to the edge of the ruler. So now the gap between him and the edge is even bigger. And then lastly, 5 minutes into the process, we end up with this picture over here. So what we can say is the following, that the ruler moves at 5 centimeters per 5 minutes relative to this guy over here. This guy, the little dude, relative to the ruler, moves also at, okay, so the velocity of the little dude relative to the ruler is also 5 centimeters per 5 minutes. But this means that the velocity of the little guy relative to the big guy is 10 centimeters per 5 minutes. So in other words, if we use vectors to represent these velocities, then the velocity of the ruler is an arrow of length 5, so that looks like this, and this represents, okay, the velocity of the ruler relative to this guy. The velocity of the dude over here is also 5, so that's 1, 2, okay, there you go. That's his velocity arrow, okay? Which means that what this guy standing at the starting line sees in terms of the little guy is effectively 10 centimeters every 5 minutes, right? You see he moves 10 centimeters within 5 minutes on the clock. Okay, so I hope this kind of very detailed analysis is giving you some insights into relative motion. Okay, so remember, we use the word relative because if we measure relative to the starting line, the ruler has a velocity of 5 centimeters per 5 minutes. The little green guy has a velocity of 10 centimeters per 5 minutes relative to the starting line. But relative to the edge of the ruler, the little green dude has a velocity of 5 centimeters per 5 minutes. See that from here to here. Now you might ask yourself, if I use instead this edge as my starting line, what's the velocity of the green guy? Well, that would be negative 5 centimeters per 5 minutes. Okay? If you were standing on the edge here and not moving, you would see this guy here moving away from you at 5 centimeters per 5 minutes, or to the left. There you go. So this is an introduction to relative motion. I hope it's been helpful, and remember, in this case, to represent the relative velocity of the green little dude to the big green dude, you just add the velocity of the ruler and the green little dude. So what you have is the velocity of the ruler, and you add to it the velocity of the little green dude. And what you have is the total velocity relative to the big green dude. That's it. Thank you for watching.